This is the Bambu Lab P2S, and it was definitely the most confusing thing I've ever received from them, because having just heard the announcement for the tool changing thing, I was expecting something much bigger and with a tool changer inside. However, despite being rather confusing when it arrived, I think it could potentially be one of the best printers from Bambu Lab from a maintenance or repairing perspective. Now, you may be aware that I don't really do reviews and print quality things anymore, because a lot of people already do those, and quite honestly, I find them pretty boring, so I'm not going to do that. Instead, I'm going to do a teardown, like I have with a few other machines recently, where we basically disassemble this entire machine into its constituent pieces, so I can show you what's inside and how it works. You might also be wondering if I'm really qualified for this, and it's the new Bambu! I think I am. Honestly, I don't really make mistakes. I always know what's going on. I wouldn't drop or damage anything, and of course I'm always very professional, careful, calm, what the fuck, and organised. On a more serious note, in the interest of disclosure, Bambu Lab did send me this printer for free, and I'm choosing to do a video. They've not paid me to make it, so it's not sponsored by them, but as I said, they did provide the machine. However, I would say it's sponsored by my own shop. I run a shop to fund being able to make YouTube videos for all of you. So if you liked this video, it was informative, or you enjoyed it, maybe consider heading over to the shop, where we sell things like calibration designs like cauliflower and cali lantern, or functional useful things like the heatset insert press. Check out vector3d.shop via the link below. Right, let's get into the meat of the teardown. Starting around the back, I remove all the wires and tubes which connect the multi-material system to the main extruder and nozzle of the printer through the ports at the back. I move the AMS out the way and remove the filament buffer. Luckily, only 2 screws here and a nice latch on one side with the electrical connector on the back. This buffer now has a manual slider to give you better access to the PTFE tubes. It also acts like the old AMS hub, as it has 2 material inputs. Once disassembled, we can clearly see how the arrangement of magnets and Hall effect sensors allows for triggering of the filament buffer as the filament length shortens. We also remove the external spool holder and loads of screws from the rear panel. There's an extra secret screw hidden behind the pass-through for the PTFE tube, so you just have to slide that out to the right, and then you can get to the screw located behind it. I'm not too sure if this is either a little bit sneaky or just a factor of inherited design from previous iterations with the new additions like the new pass-through. Whilst I'm here, I also remove some of the screws that are holding on the side panels. Just a reminder, as I'm taking off this very familiar looking door, I don't have any instructions or guides or anything for doing this. I'm literally just winging it the whole way, making guesses as to which step is next. So if it looks like I'm doing it in the wrong order or I have no idea what I'm doing, you're probably correct. Fans of the P series by Bambu are going to be really happy to see an LCD display finally on the printers, since the old one, as far as I can tell, was pretty annoying, pretty slow, pretty limited information, and just generally not great. This one pretty much matches the X1 Carbon and H series printers. Disassembly of the LCD to this level was pretty easy, but going any farther seems pretty prohibitive, and I don't think we're going to learn anything else. This I did find interesting though. Yes, it is just a hinge, but I thought it was interesting that it's basically a laptop hinge. Next up, it's all aboard the struggle bus as I hunt for screws that are holding on the side panels. They're all over the shop, and if no one's pointing out where they are, some of them can be quite difficult to find as they're really not obvious. Whilst this bit did take me a little while, it was mostly just because I didn't know where they were. I think if I had instructions, this would have been actually kind of trivially easy. All the screws were reasonably accessible, even though some were in places that you couldn't really see. These ones under the base took me a little bit longer to find than I had expected, just since I always forget to turn the printer over when I'm doing a disassembly. When I found this screw under the foam tape, I thought they put the foam tape there to hide the screw, but I think it's actually there to reduce noise and prevent damage to the drag chain. The bit that really put me off, to be honest, was the screws that come down through the top. There's no holes in the foam tape which protect the glass, so the only way to deal with them was basically like trying to cut out parts of the tape or ripping the whole lot off. I tried both and neither worked really well, although I think pulling the whole tape off in one go will result in a better look at the assembly at the end. I did try and avoid it because I know it's going to look bad when I put it back together, but I didn't know any other way. I couldn't find any more screws that attached to the panel directly, so now I'm looking to remove this fan, which clearly has some screws that go through to the panel. I'm just not sure what is holding what on. At this point, I'm really struggling to find screws that are holding this panel on. I can't obviously see anything. And you're just about to understand why. There's these diagonal screws that go in through the side, a bit like the ones at the front, also at a diagonal, but they're so far in that they're just impossible to see. Black screws on a black background in a dark area, no chance. Obviously, with the manual, they'd be pointed out, and they're pretty accessible with the driver once you see them. With those screws removed, the panel comes off quite easily. You can see this is the right one with the R, and as you can see, it's a single large injection molded piece. That gives us full access to this fan assembly, which, weirdly, is probably my favourite part of the printer. This assembly has this very large fan in the middle, a flap below it and above, and a small control motor on the left-hand side, which controls both flaps simultaneously. In its first position, the bottom flap is open, allowing cool air from outside the printer to get to the fan, allowing airflow out of the top vent across to the print. This is basically the cooling configuration. This is ideal for printing something like PLA, where you're drawing cool air in from the outside and blowing it across the print. In the second position, the bottom flap is now closed, meaning the fan draws air through the part at the rear of the printer, which is pulling from the internal build volume and through the carbon filter. The yellow flap will now sit in its horizontal position, blocking the duct towards the print and instead just venting it slowly out the side into the general build volume. The reason I think this is cool is based on my assumption that the fan is the most expensive component and everything around it is making best use of that expensive part in as many ways as possible. Here is also a comparison between the carbon filters, which you can find in the X1 Carbon, H series and this P2S. Removing the other side panel is also a little bit complicated, as you have to take out this plastic cover first and the two screws which hold in the drag chain and part of this cover. Soon I'll hopefully find the rest of the screws for this. I also try and get out this power connector, but I just can't find the last screw that's holding it in, so I ignore that and move on to something else. This is the nozzle wiper cleaner module thing. Comes out very easily. It's a slightly different design to what we've seen previously, but fundamentally has the same kind of idea, where the toolhead pushes a lever to clean the nozzle. It looked like the next step might be removing the bed, so I started with the clip, which holds the mains wiring, and does a bit of strain relief, I guess, on the connectors, and also helps ensure that the wire moves in a predictable way. I also removed the poop chute here, just to give me a little more access into the electronics area. And yes, I need a turntable that can lock in place. And with that, the side panel also came off, which I didn't expect. Down in this corner, we have 3 earth or ground connections. One of them goes to the bed, one of them goes to the enclosure of the power supply, and the other connects directly to where the power comes into the machine. With the electronics of the bed now detached, we can work on the physical attachment around the front. This is very simple. There's just 2 screws that connect to each of the kind of Z motion system parts. There's actually 3 at the back, and then the bed just kind of lifts out. Except it doesn't. As you can see here, I'm struggling to try and move the bed, thinking that I'm doing something wrong, when it's actually still attached. I also found some spaces, but I don't know why they're used. This is the extra clip. It just basically secures the bed wires to the Z mount and makes sure that there's no extra strain on the wires as the bed moves up and down continually. I thought then it would be really easy to remove the bed and everything, except it still wasn't. Everything is now technically detached, but you do have to pull quite hard to get the whole thing out, which just felt a little bit awkward given that I didn't want to damage the wires or anything. Bambu are pretty well known at this point for making a particular style of bed, where they use this kind of heater element attached to a die-cast piece of aluminium with a bunch of thermal paste. And I just opened it up quickly to check that that is exactly what they've done here, and it does seem to be exactly the same. One difference I did notice is that there seems to be a second channel for another heater. Maybe in a 120 volt printer, they double up the heaters to half the overall resistance and therefore compensate for the slight loss of power. I found another screw to remove, but still can't remove this F-in power inlet. So I turn my attention to the AP board and all the wires that connect to it. One of those items is the webcam, which has this really nicely stuck down ribbon cable, which should hopefully go back okay. I couldn't work out how to actually remove the camera at this stage, but I do want to point out the use of extra tape to make sure that the wire doesn't scratch against the frame. Since it connects into the AP board, I next remove this front panel piece, which I had loosened earlier, but now can fully remove, after fishing out the extra tiny little cables that go through this hole in the frame. This is that front panel piece as viewed from the inside of the printer, and as you can see there are two items. The item on the left is an antenna, and on the right is a white LED strip. It's partly held in with clips, and unfortunately I managed to snap one of these as I removed it. I'm not too sure how, as they look kind of spring-loaded and should have just come out okay, but apparently not. I think they're both supposed to look like this, and one side is broken. It's also held in by screws though, so I think I'll be fine. With the front panel removed, I can also take out this ribbon cable, which attaches the AP board to the LCD display. Also the temperature sensor for the enclosure, with this nice little cage around it, which I think should help just to stop it getting damaged by any stray 3D printed objects. Lastly, we have a Hall effect sensor for the door, just to check whether it's open or closed. I carefully remove the USB connector, and then the AP board, which reveals the reason for the weird square pattern on the outside, as there's a bunch of blue goop which connects the MCUs on this board to the frame as a heatsink. Unfortunately, we can't see any brand naming due to this heat spreader that's been used. To prevent getting blue paste everywhere, I do just put the AP board straight back in. Moving back around to the rear of the printer, I remove this large piece of plastic which helps guide the bed wire and also covers the terminals on the power supply. I unscrew all of these terminals, and these are connecting the power inlet, the bed power board and the power supply all together with just these wires. There's also a little cable tucked in here using like an XT30 or something, which does the low voltage supply from the power supply to the main control board. Unfortunately, no great photos of the power supply, but I do know it's by Megmeet and it's a 24 volt supply. My plan of action is now to remove this whole back internal electronics panel piece. So in order to do that, first I need to remove all the remaining wires from around this area, and then detach the heatsink, the big massive copper block that attaches it to the frame, from the control board. Luckily, the screws for this part are all quite easy to locate, except for the ones under the power connector and under the little plastic part by the Z rod. Once those are all out and the heatsink is detached, the whole panel just kind of comes out. Needed a little bit of wiggling just to get it around the little latches and stuff to hold it in, but it all comes out pretty easily in one piece. And this is our first chance really to take a look at how this heatsink slash copper block is really functioning. As you might be able to tell from the tone of my voice, I'm not hugely impressed by this. I get the impression that this was not their first solution. In other printers, they've got fans in this location to help cool the parts that are driving the stepper motors. Obviously, they wanted to try and go with a passive design. I feel like this can't have been their first choice. There must have been other solutions, and they just didn't work out in the time that they had, and they ended up going with this with a bunch of paste. It doesn't really seem like Bambu. A lot of their stuff seems well designed in advance. It works, they get it made, and it's done, and it's exactly as planned, whereas here, it looks like things didn't work out, and this is what we end up with. If we go by the naming used by other Bambu printers, then this board with the blue paste is the motion control board and has the stepper drivers, stepper motors, and a few other connectors for other motion-based functions. And then this second board down here is the mains power board, where mains comes in and is sent off to the bed. So basically like an SSR. Next up, we have the little sticky out arm mechanism, which is used for the filament cutter. In the X1, this was just a spring-loaded lever at the front of the printer, and in the H2 series, we saw the rotating arms as the tool head moves to the back of the printer. This is much more similar to the H2, but with a small metal arm that sticks out instead. As you might be able to tell, I find this pretty satisfying. Next, it was time to move on to the frame. And to me, it looked like there was a big C-channel that was a kind of sheet metal welded fabrication that goes all the way around the top. This is where you can see the AP board is mounted within that C-channel, and it looks like that whole assembly can just be removed, although maybe with a little bit of persuasion too. So I started removing every single screw that I could see that would attach this C-channel frame down into all the other parts of the machine. One screw had been shredded though, so I had to use some pliers to grip it and turn it out manually. Before continuing, I decided to remove the front of the tool head. To this day, I have no idea why. My initial plan here didn't really work out because, as I saw with the H series printers, there are these little pips on the frame, and that makes all the panels kind of lock in together so they can't actually slide past each other without first sort of coming away from each other. So more screws, more disassembly, more randomly taking stuff out, hoping that we'll find a way that everything comes apart. The only parts really left here are the external frame, the gantry, and the base. So as long as I can separate those three elements, then we're making progress. In some of the Bambu printers, the feet are actually screwed on and into the frame, and that makes them kind of part of the structural assembly. But these ones, they actually just push into the gaps and the screws are separate. So at any time, you can pull the feet out if you need to, and it actually makes the printer much easier to move around because now the base is slippery instead of grippy. The last bit holding it together are the cross braces, so removing the screws on those should allow me to remove the vertical pillars, as they can then basically move away, releasing the pips. And there we go, the part comes out. I just repeat the same process of moving the cross beam screws on the other side, and that's then it for the front two pillars of the frame. With the front two pillars removed, the top C-beam welded assembly section all just comes away too. Just have to be careful to make sure you route the wires out as you pull the frame away. With large parts of the frame now removed, I finally spotted the last screw for the power inlet, and it's tucked behind the metal frame. The gantry is now also mostly loose, so a couple more screws and that whole gantry assembly with the X, Y, A, B, whatever, all just comes out as well. I also worked out how to remove the webcam. You just have to push back and it just slides off. With lots of the big stuff sorted, it's time to move into the tool head, starting by removing the hot end and then the filament cutter. Even though it has this very slick looking cover around the outside, this tool head is really very simple. It's a PCB on the back, an extruder, and hot end bolted to the front. The way it's put together should make maintenance much easier than previous revisions. Looking at detail at the extruder, we start by removing the filament cutter shroud cover thing, just in case that needs to be removed. This is a little demo of how it works. And then we have the filament sensor board, again just a tiny little PCB with the Hall effect sensor on it. The extruder gear comes out quite simply, and then what I find most interesting is the tensioning lever. The way that this works is that the screw and spring apply pressure to the top part, which has the inclined plane at the bottom. The force is formed by the inclined planes sliding against each other due to the downwards force, forcing the gear into the filament path. If I remember correctly, this is something similar to what the E3D Hemera used. Moving onwards, we can now take a look at removing the shroud. There's quite a few screws to do this, there's like 3 or something on each side, and this removes in kind of a split shell format from the front and the back. The screws are really close to the rods, making it kind of difficult to rotate the driver, but they're still very much doable. It's pretty easy to remove the shell, just be a little bit careful as there are some plastic clips here and you don't want to break them. Underneath, we find a pretty standard layout for a Bambu Lab tool head, with a USB cable coming in the top, a large connector for the hot end, and then a few auxiliary connectors for things like filament sensor, the motor, and of course the USB. Of course, Bambu likes to use lots of ribbon cables within their tool heads, presumably because it can save space and maybe it's cost effective, but they can be quite fragile. So just be careful, don't pull anything too hard, and I tend to use tweezers, although these are not sort of ideal either, as the metal tips can actually damage things. Despite looking a bit complicated, I actually quite like this layout. Everything is reasonably accessible, and you don't have to remove any extra screws in order to unplug stuff from the tool head, the exception of course being the USB cable, which is quite well stuck in there. Here is a closer look at the front of the Toolhead PCB. You can see the MCU there on the right hand side. I quite like that all the connectors are unique, so you can't really plug things in the wrong place. If it fits, it sits. These areas that look painted, I believe, is a type of conformal coating, which is a kind of electrical insulation as well as protecting from the elements like water and corrosion over long periods. I quite like this view of the toolhead because I think it helps show the independence of the hot end from the extruder. Because they're less integrated to each other, it makes the assembly and disassembly, plugging in and stuff, just that little bit easier. Here I'm removing the inductive sensor and hot end. The inductive sensor is used as part of the probing mechanism and the pressure change in the nozzle. I believe the way it works is it's basically sensing the deflection of the hot end away from the extruder, and that tells you how much force is being imparted. The heater and thermistor module will be pretty familiar for those of you that have seen the A and H series already. Here I'm removing the extruder motor, which is their new servo type, and it's really nicely positioned between the rods, as this should help reduce the torsional effects of fast acceleration by keeping the mass in as central position as possible. The servo motor looks kind of the same as the one on the H series, but I think it's a slightly newer version. It's certainly not as well finished. I think it might be a bit of a cost down version. I'm not too certain. We can move straight on to another feature that I really liked as well, and that's these kind of belt grippers. It seems a bit of an odd thing to like so much, but one of the things that's quite difficult is making sure that your belt capture mechanism doesn't take up loads of space in your tool head. And what they've done here is really space efficient. These end caps are actually die-cast aluminium rather than plastic, even though they match the appearance of the rest of the tool head. And then these very tiny little grip things sit on the belt, you pull it into the gap, and it holds the belt like perfectly tight. And yet, only a few teeth engaged, and in a really small space. I quite like this design, I've not seen it anywhere else, so yes, I was quite impressed. As we tend to expect from most machines nowadays, the belt pattern is Core XY. With the belts removed, I can now also start removing the ends to inspect those. They do have these weird little springs in place, which is an interesting thing. I'm not sure exactly why. It might be to do with like grounding, but I think it's more to do with like tolerance during assembly. They seem to be forcing the rods into specific positions, and I think that's part of how the glue gets into the right place. Yes, they are glued in, but they do actually come out, so I think the glue is just sort of there as a precision assembly thing, and then you can remove and insert them as you need. You can see also that the motors are fully replaceable. There's also a really neat assembly on all of the corners where you can just simply remove the idlers. So the idler bearing and the pin can just be slipped out, replaced or removed or lubricated, whatever you want to do. And then the whole thing just slips straight back in and you screw it into place. It's actually a really neat little design and I quite like how it works. With this part holding the motors, removable idlers and self-tensioning mechanism, it's quite a cool part with lots of complexity that is quite a miracle in my mind that they managed to injection mold it all in one go. There's a lot of complexity for one piece. At each end of the X-Gantry, you'll find these metal plates that hold the linear bearings in place. One, though, is spring-loaded, with these extra little tabs, while the other seems to be solidly mounted. And I think this is part of the kind of tolerance management within the gantry to make sure that the whole thing doesn't bind up in specific positions. Gone as well are the carbon rods, replaced with these hardened steel tubes instead. The X carriage is made up of two parts, a kind of front and back, with loads of screws holding them together to make this very rigid assembly. It's a fiberglass embedded plastic, so very, very stiff. And weirdly, they seem to have used a tiny bit of tape as this kind of shim, I suppose, to try and balance out the carriage maybe. Maybe there was a little gap or it is not quite straight. And it seems to just be shimmed with a soft piece of material. Again, maybe part of tolerance and binding and that sort of thing. The gantry can't be disassembled any further, but I thought the use of bushings here was quite an interesting choice. And while I do hate glued assemblies as much as you do, I think it might actually end up with a less twisted assembly as a result, so it might not be all bad. With the gantry disassembly completed, it's time to return to the frame of the printer and remove fully some of these cross beams which we looked at earlier, as well as the remaining pillars and Z-axis rods. This isn't specific to Bambu, but I'm always amazed how quickly you go from a rigid frame into a pile of pieces. One thing you might notice when this printer is new is that there's this little plate covering something on the left-hand side. Well, as it turns out, it's just the same as the right-hand side where there's a vent. So they just have a cover panel to cover it up, and I think it's used for an extra fan if you want one. The rubber grommets that surround the Z-axis rods are to give a position for the bearings to slide into as the bed comes down, but without letting plastic and stuff into the hole while there's like other stuff going on. One change on the Z-axis compared to the X1 carbon is that the lead screws are now only supported at their base and the top is just a cover. The bottom bearing is covered by this small little metal plate which holds the flanged bearing in place. On the underside of the base, we have this very familiar Z-axis layout as we've seen on other Bambu printers before. You have 3 lead screws with 1 motor and 1 tensioner. All 3 lead screws are synced together, which means you can't turn each one of them individually relative to the others. In the past, I'd have said that this is a really bad solution and that you need to do it like Ratwig, where you have 3 independent motors all driven separately so you can perfectly level the bed. However, I think Bambu have proven that this solution does work as long as you have other compensation mechanisms that do work really well. And this is all the parts. This is what it looks like when you've totally disassembled your Bambu Lab P2S. You have everything laid out on a table, and all you're left with is the overwhelming anxiety of realizing that you've got to somehow work out how to put it back together again. While past me works on the reassembly, let's go through some summary points on the P2S. Overall, I broke 4 little plastic clips, lost 1 screw. 1 screw had its head shredded at the factory, and the soft tape at the top is now kind of messy. That being said, I do kind of still stand by the fact that this is the most repairable Bambu Lab printer that I've looked at so far. And there are a couple of reasons for that. Firstly, the gantry rods and bearings can be replaced, with the exception, of course, still of the X-gantry, so still improvements to make. But the fact that the gantry rods and bearings can be greased, lubed, replaced, that does kind of help. Secondly, lots of screws were the same, which doesn't seem like that big a deal from a distance, but when you're doing lots of disassembly or reassembly, having lots of screws that just can go anywhere is really, really helpful. You don't have to remember where they go or make sure you're in the right place. They just kind of go where they go. In general, there is one screw that goes into plastic and one screw that goes into metal, but at the moment there are still lots of unique applications for many other screws, especially in the tool head. But hopefully this will continue to improve over time and we'll see the number of screws reduce and reduce. And lastly, the tool head is way more approachable in terms of maintenance. For example, this PCB here is just used as a way to convert one connector to another in a convenient location at the front of the tool head, making disassembly easier. It has really no other purpose. The idler brackets were also really cool, the way they just kind of screw in, hold them in place. They sort of all seem to self-align rather well. And yeah, overall just a really neat way of accessing those idlers at pretty much any point if you need to maintain them. Another highlight in a similar vein is just the number of access holes and stuff that are now here in order to unscrew motors and things without having to do major disassembly of the machine like you saw with what I was doing. Of course, despite there being plenty of good things to mention, there are some things that I would still call negatives. For example, some screws are still difficult to access. Certainly some around the external panels where you really had to dig deep into a screw that was in complete darkness and you could not really see it. Of course, with a manual, you'd know where it is, but I think something that's more easy to access would be preferable. Secondly, the whole blue goop situation. Personally, I don't feel like heat sinking to the frame is the best solution. It might seem like a good one at the moment. It certainly seems to work. I've not had problems with failure, but the whole blue goop messiness just doesn't seem ideal to me. Also, their selection of spares are still set up as assemblies rather than parts. So if one thing breaks, you generally need to replace the entire assembly rather than just the single tiny bit that broke, just because that's how it comes. It does mean you can still do maintenance, but that component might end up more expensive because you're acquiring more than you really need to. And lastly, the whole plastic clip situation. As I mentioned, I did break 4 clips during my disassembly, mainly because I didn't really know they were there. I tried to pull it apart and the clip broke. This is pretty typical for plastic clips, as many people that work on cars will probably tell you. I understand their advantages in terms of assembly because you just push 2 things together and suddenly they're attached. But when it comes to disassembly, identifying the clip and the exact way you have to press on it or press against it in order for it to release, just generally results in them being broken and therefore they may as well not be there in the first place. So there we go, my Bambu Lab P2S is now fully reassembled, all the screws are back in, and it's ready to print. If you enjoyed this video, don't forget to leave a like and subscribe, and if you want to get one of these, there's an affiliate link down below, which doesn't cost you anything extra, and will give me a small kickback from the sale. Thank you very much for watching, and I'll see you for another crazy teardown next time.